নমস্কার, আমি বিক্রম। আর আজকে আপনাদেরকে আমি দেখাতে চলেছি আর.এন. মুখার্জি হলে 15ই ডিসেম্বর যে সেমিনার হয়েছে তার বেশ কিছু অংশ। তো এই সেমিনারের মূল বিষয়বস্তু ছিল কলকাতা তথা ভারতবর্ষের যে সমস্ত ব্রিজগুলো রয়েছে সেই ব্রিজগুলো যে আর্কিটেকচার বা তৈরির যে করণ কৌশল সেই সম্পর্কে আলোচনা করা হয়েছে এবং কলকাতার বিশিষ্ট ইঞ্জিনিয়ার্সরা এই করণ কৌশল নিয়ে তৈরির প্রক্রিয়া নিয়ে তারা আলোকপাত রেখেছেন বিভিন্ন বিষয়। তো আসুন আমরা জেনে নিই যে তিনটি সংগঠন এই সেমিনারের আয়োজন করেছিল তারা হলেন দ্য ইনস্টিটিউট অফ ইঞ্জিনিয়ার্স, কনসাল্টিং ইঞ্জিনিয়ার্স অ্যাসোসিয়েশন অফ ইন্ডিয়া, ইন্ডিয়া অ্যাসোসিয়েশন অফ স্ট্রাকচারাল ইঞ্জিনিয়ার্স। এই টোটাল তিনটে সংগঠনের প্রচেষ্টায় এই সর্বাঙ্গীন অনুষ্ঠানটি সাফল্যমণ্ডিত হয়েছিল। তো দেখতে থাকুন।
with special emphasis on cable joints and bearing, covering the aspects of maintenance and instrumentation and measurement. Once again, welcoming you all. May I now request Engineer Sandeep Kumar Dev, Council Member IEI, immediate past Chairman and Chairman of Architectural Engineering Division Board, to kindly deliver the welcome address.
Can be implemented by experience, even if you do not have that kind of institution of education. Ladies and gentlemen, well, once more welcome to this R.N. Mukherjee Hall of the Institution of Engineers India West Bengal State Center. First of all, I would like to thank the Joint Secretary of Institution of Engineers West Bengal State Center, Anirban Dotto, to plan for such a wonderful program with CEAI and Indian Association of Structural Engineers. We used to tell that nowadays engineering is has become a multidisciplinary subject. But when we organize programs, we used to do it either in the edges of civil engineering or mechanical engineering or electrical engineering. But this program has shown that yes, if you want to do some progress in infrastructure, you need to have almost all kinds of engineering. When we talk about the bridge engineering, it's not the only domain of the civil engineers, it's not the only domain of the mechanical engineers. It belongs nowadays to almost all kinds of engineers. Even when we see that the brilliant civil engineer, the bridges, world-class bridges, there we see the effect of wonderful architecture also. Generally, we used to see that architects are there to make the building, but nowadays the big bridges, they are taking the help of architects also. If you go to China, you will see that not only in China and US, which are in the two opposite sides of the globe, but in all their bridge projects, you will find the presence of an architect. Because nowadays, the brilliance is not only in structure, but also how much wonderful it looks. That also makes an effect. So, thanks again to all the organizations who are jointly organizing this program. And I would like to conclude my welcome address just telling you a few things about the Institution of Engineers, because today I am observing a number of new faces here in this hall who are not there previously. In fact, we used to say that now Institution of Engineers is becoming a hub of plus 40, if not plus 60. But really today I am very glad to see that most of the the audience is if we calculate the average age of the audience here, I don't feel that it will cross 40. So that's why I cannot resist myself to tell a little bit about our Institution of Engineers. You must be knowing that the Institution of Engineers was established in the year 1990. So we crossed the century mark in the year 2019. And our West Bengal State Center, that time it was known as Bengal Center. The entire Orissa, Jharkhand, Bihar and all the northeastern state along with the West Bengal was there under the Bengal Center. We were the very first state center under the Institution of Engineers India, and headquarter was there, in 2019 itself it was there in Kolkata. And actually we have 15 number of disciplines starting from civil, mechanical, electrical, and we have small divisions like textile, marine, architectural engineering, mining, aerospace. All 15 divisions are there under one umbrella of the Institution of Engineers India. Not only the division, but there are fora, different forums like Rural Development Forum, Sustainable Development Forum. Under the head of these forums, the Institution of Engineers reach directly to the common man. See, here the program has been made, and I believe that most of the participants here are basically engineers. But the forums, through forums, the Institution of Engineers reaches the common man of India, like RDF, the Rural Development Forum. It is here in Kolkata, the head office of the Rural Development Forum in Kolkata. And through this forum, we used to reach the interior of Sundarban area, interior of Orissa, interior of every state, to reach the common man, to show how technology can help them in their daily life. Institution of Engineers not only there in all parts of India, but we are there in other countries also. In Abu Dhabi, in Nepal, in Bangladesh, in US, and in other countries also we have our centers. The students who are present here, you can be associated with the Institution of Engineers from your student life itself by forming a student chapter. If you are a student of a graduate engineering college like Bengal Engineering, now it is IIEST, I'm so sorry, because always it comes to me Bengal Engineering College because I passed out from there. If you are there in IIEST Shibpur or any, even in private engineering college, you can form your student chapter in the name of your engineering discipline. That means if you want B college, if you are in IIEST Shibpur, in civil engineering division, you can start your IIEST Civil Engineering Institution of Engineers student chapter. And if you are a member of the student chapter, then once you passed out from, once you complete your graduation, you will get a benefit, a large number of benefits while you will become a corporate member by filling up the form of an AMI, Associate Member of Institution of Engineers, and immediately you will become a chartered engineer. That's a big thing because apart from the ICE, Institution of Civil Engineers UK, only the Institution of Engineers India can provide chartered engineer certificate to its members. So with these few words, I would like to conclude. Thank you very much, and once again, welcome to this memorable hall of, in the name of Sir R.N. Mukherjee, and enjoy the program. Thank you very much.
Sandeep Kumar Dev very lucidly described about the history, background and activity on arms of IEI. Now, as you are all aware that we are organizing this event jointly I would now request Engineer Saurabh Das Patnaik, Chairman of Eastern and Northeastern Region of Consulting Engineers Association of India, to kindly share a few words about the CEAI.
We are having this August gathering after many efforts of people like Anirban, Dr. Bhushal, all of us, Dave, and many of you who have tried to work together to make this program, unique program, happen. Consulting Engineering Association of India, based headquartered in Delhi, having its governing council, having overall more than 650 members, including institution members, I think more than 400 members. Today, why are we meeting here? What is the reason for it? The fundamental aspect of engineering, and as Mr. Dev mentioned from institutional engineers, that cross-functional knowledge, interdisciplinary science and engineering is necessary to come out with practical solutions to long pending challenges. And engineering itself by nature is interdisciplinary, and more so when we are looking at complete solutions from any perspective. You mentioned about need for architects, also in bridges, similarly in highways, railways and transportation. In water treatment plants, talking about enhanced design. So need is there to collaborate, coexist and cooperate. Competition is a way of life, but cooperation and collaboration is more healthy. And I think today these three institutions together who have collaborated to come together for a common cause is really unique. Seldom we see this kind of association together with a common purpose. And the topic also is very, very unique, that people will like to enhance their knowledge and also exchange their ideas and knowledge. So CEI, as a member organization of FIDIC internationally and the only member organization in India, also places very important role for international contracts and the consulting for engineers. Indian engineers are across the globe. They are participating in the growth story, in the infrastructure story, engineering story of many countries. And we believe that Consulting Engineering Association and its eastern region and the northeastern region, where all of us are located here under the guidance of Mr. Ghoshal, our mentor and past president of CEI. We believe that CEI has a very active role to play, especially for Consulting Engineering Association, especially for the consulting and engineers who are into consultancy, including the PMC. As you see, large investments are made in infrastructure, but very seldom you will find the consulting engineering and engineers are getting maybe 0.5% or 1% of the total financial impact. But it is necessary to manage the projects, to ensure that the projects are on track, to ensure that the projects are well designed, and even when there is arbitration or issues of dispute, CEI plays an important role in mitigating that. So, without enhancing and extending my speech further, we are running short of time right now. We really wish this entire exercise and going forward, such collaborative efforts happening, and in fact, the Calcutta has been the fulcrum of engineering right from last 150 years. So I think we have to bring back the glory, and Indian engineers, institutional engineers, CEI and Institution of Structural Engineers, all of us will work together to make this happen. And thank you so much for your patience.
May I now request Engineer Anirban Sengupto is the Vice President of Eastern Region, Indian Association of Structural Engineers, to kindly share the activity of iStruct.
I must thank to the all organizing people, but in a very short time, just a 15 days, we are able to organize this event of panel discussions on this subject. Many thanks to all organizations and our speakers and taking part, and those who are sponsors, specifically Mrs. GPT, Fresine, Mageba, Usha Martin, PSL, and Swatch India. So I must thank all of them to support in a very short time and contacting them and to make us able to organize this event. Indian Association of Structural Engineers is promoting structural engineering big way. Number of people, all of you know that we are organizing number of webinars, number of courses, number of structural engineering courses, and one day, half a day lectures. Number of lectures are no registration fees are also there, and the form of webinar also there. Even like this offline things are also there. And lot of publications are also there, which is IRC code guidelines, and lot of things are there. So not elaborating. And also one more thing, we are helping to getting an international professional engineers certification. For that, iStruct is also helping our people. So all these things are there. I am just showing a short video about the iStruct activity.
Professional structural engineers from all over the country. iStruct is registered under the Society's Registration Act 21 of 1860. iStruct is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, iStruct has been led by eminent structural engineers like late Sri Mahindra Raj, late Sri Kumar Ghosh, Sri Subhash Chandra Mehrotra, Professor Mahesh Chandran, Sri Alok Bhaumik, Sri Manoj Mittal, and Professor R. Pradeep Kumar. As its president, iStruct is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, iStruct has collaboration with various international professional like-minded associations and institutions. iStruct's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. iStruct endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. iStruct is actively engaged in organizing several continuing professional development CPD courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. iStruct's activities are widely appreciated and known for quality technical contents. iStruct is also actively engaged in publishing its quarterly journal Structural Engineering Digest SPD, code commentaries, professional guidelines, and a monthly newsletter. iStruct's publications are becoming popular with time. iStruct has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to national code of formulations. In the year 2020, IE instructees started national awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IE Struct is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IE Struct has its student chapters in several leading engineering institutions as well. Membership of IE Struct is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IE Struct is available on its website www.iestruct.co.in.
All together with IA Institute of Engineers and along with Consulting Engineers Association of India, I must thank them that they also, all of us, hold hand and done very properly to able to organize this. So let us see, you all will say at the end of the day that how nicely we have organized and course matter has been designed. So with this, I must, I thank all of you for the whole, expecting that good day will go on at the end of the day. Thank you very much.
Theme will be depicted and some facts about late engineer Mahendra Raj by none other than engineer Amitabh Ghoshal, past president of CEI, past council member of the Institution of Engineers India, and former director and vice president of Stuck Consultants. Although engineer Ghoshal needs no introduction, he is a civil engineer of international repute. May I request now engineer Amitabh Ghoshal to kindly share the theme of the program and information about late engineer Mahendra Raj.
Standing here, I really feel the days of the pandemic is over. What gives me greatest pleasure is to see the hall more than 80% full, which has not happened for the last 3.5 or 4 years. It shows that we have got over the influence of COVID and we are free and ready to come and congregate and exchange our thoughts. It's a great feeling. And this event was organized basically to achieve this end so that we can have again live congregations where we can discuss freely across the table or across the I am very grateful to those who have come and filled the chairs, and very soon we hope the entire hall will be full. This event had been designed such that different organizations can come together and contribute, and different disciplines can participate. We don't have only civil engineers or mechanical engineers or chemical engineers. We have got engineers from all across the discipline. That is the beauty of this particular event. Now today's event, has been called the multiple facets of cable supported infrastructure. Not only bridges, but cable supported infrastructure. And as Mr. Datta has mentioned, we dedicated this event to the memory of Sri Mahendra Raj, one of the very senior engineers who had ruled the engineering scenario not only by his capable engineering but by his capable leadership. First, I will talk about the event. Sorry. Well, this half-day event that we have planned is going to cover cable-supported bridges and then cable-supported infrastructure and how to make infrastructure sustainable with proper inspection, maintenance and health monitoring. We covered all of that. The first session, session 1, is dedicated to cable-supported bridges. Now, in terms of cable-supported bridges, there are actually 3 types. One is suspension bridge, which provides bridges to be spanned very long distances. The longest bridge in the world is about 2 kilometer span in Japan, and that's a suspension bridge. We have all seen pictures of Golden Gate and various other suspension bridges, and you will be very interested to know that suspension bridge had been invented in the southern Himalayas in India. India gets the credit for suspension bridges, just as the Chinese get the credit for the cantilever bridges and the Romans get the credit for arch bridges. Very few of us know this fact, but it is recorded. Now, today's event we are going to talk about 2 types of bridges. That's the cable-stayed bridge and the extra dose bridge. Reason is very simple. Calcutta has both, and the longest cable-stayed span in India is in Calcutta. And the first extra dose bridge, which earned international eminence, is the Nivedita Setu in north of Calcutta, and both of these are part of our life. That is why we thought that we will have an event on this subject. Now, what we will cover in session 1 in the cable supported bridges, one should understand what is the speciality of cable supported bridges. I will give you one example. We all know about the 2 great bridges we have, both are international recognized. One is Howrah Bridge, another is the Vidyasagar Setu. Howrah Bridge has been a game changer, one of the first bridges in the world to use high tensile steel, that is high grade steel, which was manufactured in India, and it required 26,500 tons of steel for a length of 600 odd meters, which is roughly 40 tons per meter length of the bridge. The Vidyasagar Setu, which was built about 50 years afterwards, the first one was inaugurated in 43, whereas the next one was inaugurated in 93. It has a length of more than 800 meters and it consumed only 14,000 tons of steel, which means per meter steel consumption is only less than 20 ton per meter. You can imagine how sustainable a bridge becomes with the use of cable. And they have got, if you are thinking they are different, no, they have got the same width, same carriageway and the same loading. Even then, this consumption of steel has been halved, and as a result, it is extremely sustainable structure, because 1 ton of steel produces 2 tons of carbon dioxide, and therefore we have saved that much of carbon footprint by using a cable supported bridge. And this sustainability comes from 3 major factors. One is cables have got much higher strength than structural steel. Secondly, there is no limitation of length. You can have any length of cable. As I mentioned that the bridge, longest bridge is 2 km long, and the cables go unspliced for that entire 2.5 km that the cable length is. And with cables, you can arrange them in multiple forms. In steel, you have got given forms either as an arch or as a truss, whereas with cables you can play around. You can have a suspension bridge which is a cable stayed bridge which is symmetrical. You can have an asymmetrical bridge. The signature bridge is very different. And what we are going to cover through the best exponents in the profession. First is the design challenges, and this design aspect will be dealt by Mr. Anirban Sengupta, who had been the Chief Technical Director of Stoop Consultants and has experience of many cable supported bridges. The construction aspect will be dealt by Fresine, and we have Megan here who will make presentation, and another part of the construction, repair and rehabilitation will be covered by BSF. So we have got the two largest players in the field of cable supported bridges, that is Fresine and BSF. And GPT also is practical utilizers of these skills. Then material is very important, the cable material, and for that we have the largest cable manufacturer and internationally acclaimed for a very, very long time. Even when Vidyasagar Setu was thought about, nobody thought of going outside for cables. We approached Usha Martin, and today presentation on the material will be done by Usha Martin. Inspection and maintenance is a very important subject for cable supported bridges, because when you take high strength, when cables are pulled always in tension for its entire life and in a very high, with a very high force, you require to take care of the cables. If you don't take care, then disaster follows. And it has been seen all over the world that cable supported bridges have suffered distress with time because they are permanently in tension, and with that tension, and when they are not protected fully, there is chances of corrosion which you cannot detect. So this aspect of sustainability and inspection will be handled by Professor Nijjat Dham, who is at present member of the technical advisory group overseeing the repairs of Vidyasagar Setu. You all know by newspaper that the bridge is under repair, and this week itself the first cable of the out of some 30 cables that will be changed, the first cable is going to be changed either by the end of this week, by maybe Sunday. So we cover all aspects of a bridge in this particular presentation. In the second session, we are going to talk about bridge sustenance, and that will cover the monitoring. You know, bridge, this health monitoring of a bridge is very important, and as I mentioned, for cable supported bridges it is even more important. And we have Mageba, one of the international players with a very strong office in Calcutta. They will be making a presentation on the monitoring systems for structure, and they will also make a presentation on the bridge appurtenances like bearings, expansion joints, seismic arresters, seismic supports, and that would cover the main part connected with bridges. Then we have a third session, which is cable in infrastructure. You know, today cables are being increasingly used in the infrastructure, we are making transportation through ropeways, we are making human transportation through cable cars, and these aspects which are seldom discussed or seldom exposed will be done by an exponent who is very well known in the industry, Mr. Shekhar Chakraborty. So this is the brief fair that you have in front for the next 4 or 5 hours, and I request that all of you get involved and kindly send questions after the authors make presentation. In written form, you have been given a pad and pencil, so please give questions only in writing, not verbal. We are not going to call people for making questions. Please send your questions, our volunteers will collect, and this will be replied jointly by the authors. So please get involved, please make this event successful and event proactive. I will now talk briefly about Engineer Mahendra Raj. He has not been very well known in the eastern region. His place of work had been Delhi, and he has been working around the country, abroad as well, but he has been much more known in Delhi because of his continuous interaction with the industry. He was an engineer of the past era, when people did not have computer, people did not have program, there was no finite element to help them, and engineers used to work based on their intuition and their knowledge. And that is what Mr. Mahendra Raj was. He had done unusual asymmetrical structure, three-dimensional structure, all based on his understanding of the flow of structural forces. He had the opportunity of working with famous architects of the world, Le Corbusier, Louis Kahn, Charles Fourier, Balkrishna Doshi, Joseph Allenstein. Raj Rewal was the last in that line, and he had given shape to the vision of an architecture. Whatever the architects wanted, he had been able to produce in structure. That was his main achievement, and some of the structures which had remained ingrained in engineer's mind is like the Hall of the Nations in Pragati Maidan, which has been recently demolished and given to another structure. Then Salarjung Museum, the sports complex in Ahmedabad, all these bear his stamp of authority. But he was a visionary institution builder. It is he who helped give CEI, Consulting Engineers Association of India, the shape it is in today. It is he who founded IS Tracti and made it rapidly into a very dynamic organization which is serving the profession, which has made engineering as a live profession. And he had also led the battle for getting engineers recognition. It is unfortunate that engineers, particularly in our country, do not get the recognition that professionals should. We have laws covering doctors, lawyers, even valuers, but we don't have an engineer's bill as yet. He had fought for it 30 years, but he ultimately had to leave this world without seeing this footage completely done, and leaving that task to all of us engineers who has outlived it. And he worked until the last day he had been working, and he died 97 years old very recently, and all of us used to call him the Vishwapitama of engineering. He was in his old age, he used to guide engineers all over the world. So we remember him today, friends, as a visionary engineer, as Mr. Shandip Dev mentioned about another great engineer, Mr. Sir R.N. Mukherjee. Similarly, Mahendra Raj, unfortunately, He had been nominated for Padma Shri number of times, but he did not get a national award because engineers are not really recognized the way they should have for their hard work. It is we who have to fight for it. Thank you very much. Thank you for coming, and we look forward to a vibrant event. Thank you.
So, so nicely he had touched upon the theme of today's event and the life sketch of lead engineer Mahendra Rai. We are now moving forward towards the technical sessions, but before we start our technical sessions, it is customary our part to honor the dignitaries on the dais. May I request Engineer Sandeep Kumar Dev and Engineer Saurabh Das Patnaik to kindly felicitate Engineer Amitabh Ghoshal. I now request Engineer Chandrachud Bhattacharya and Engineer Saurabh Das Patnaik to kindly felicitate Engineer Sandeep Kumar Dev. May I now request Engineer Chandrachud Bhattacharya and Engineer Anirban Sengupta to kindly felicitate Engineer Saurabh Das Patnaik. I now request Engineer Anirban Sengupta and Engineer Chandrachud Bhattacharya and Engineer Sandeep Kumar Dev to kindly felicitate Engineer Anirban Sengupta. Thank you all. With this, the inaugural program is over. We now move forward to the technical session. May I request the staffs of West Bengal State Center to kindly prepare the dais.
Engineering is a vast subject, a very large subject. Covering this within 20-25 minutes is a very difficult task. So I will try to touch upon just some basic and some important aspects only, and with some examples. A lot of nitty-gritty, lot of detailing aspects, lot of important aspects. Specifically, pylon head design itself is a very large task. So even the girder where we are stressing that part, detailing and designing is also a big task. So I am just covering small, as the basics, try to clear it out whatever possible, try to justice whatever possible within short time. So my covering the detail, that type of cable supported bridges, preliminary dimensioning concept, conceptual structural behavior, cable arrangement and protection system, anchorage system. Anchorage system I will go fast, very fast I will pass on, because President and PSL, they are going to talk about this anchorage system in detail. So, and some design issues with some examples, and the construction stage issues, conditions, how to do PTN. But construction stage design, case to case basis changes, because how we are going to do the construction, what is your equipment you are going to use, what is your construction scheme. So I am just going to show you one example only. So this is this you all know, in Calcutta, Vidyasagar Setu and Bardhaman ROP, both of you know, both are cable stayed bridge. One is, top one is a symmetrically Vidyasagar Setu, and Bardhaman is a very asymmetrical constructed cable stayed bridge. I will come a little more the issue on the detail. These are the two extra dose bridge. extra nose bridge, bottom one is Nivedita Setu, which is a symmetrical extra nose bridge, whereas Durgam Cherbu over a lake in Hyderabad, which is again a very asymmetrical bridge, 233 meter central span, and the anchor span is only 66 meter. So very asymmetrical. I will come back to that detail. What is extra nose and what is cable state, the differences. Now, with the preliminary dimensioning concept, I just showing that what are the dimensioning concept changes, the vertical height of the pylon and with respect to the span and the anchor spans and the depth of the girder. So these are the important issues where it totally changes the concept of cable state and the extra nose. Now, in a pylon height, in a cable state bridge, if you see most of the pylon heights goes about span by 4 to span by 5, and spans adopted large spans. Cable state extra nose bridge, what I have seen that up to 275 meter, like in Durgam Cherbu has been done to 33 meter, 275 meter, little more than 275 meter, little shed, little more has been constructed till now. But in cable state you can go further, much more. You have seen lot of 500 meter, 1 kilometer long bridge is also there in cable state bridge. Side spans are the side means back spans, but the main span, the side spans, that is what I have shown in as L1, which you can go up to 0.4 times the main span also. Span to depth ratio, the main span depth is much less compared to the extra nose bridges. So this becomes around, ratio becomes 50 to 250. It depends on how high what is the height of the tower, the pylon, and the angle of the cable. In cable state bridge, fatigue range is much higher. That I will explain little later. Why? Because fatigue range was proposed as a higher in the codes and in the standards. Cable sizes required are higher, anchorage sizes are higher, and cost is also higher compared to the extra nose bridge. Whereas extra nose bridge pylon heights are generally span by 8 to span by 10. When I am talking about the pylon height, it is from the deck top, from the top of the deck. Spans are adopted generally 275 meter. Side spans are basically the back span, the anchor spans are 0.5 to 0.6 meter, 0.6 times the main span, and span to depth ratio, here the support is higher, 25 to 50, and at the mid span you can further reduce 50 to 100. Angle of the cables are much better and lower fatigue ranges as per the Udal guideline. These also, both the things I will explain together. Now, conceptual behavior of the structure in a garden bridge and a continuous bridge, if you see on the, let me take the, in the garden bridge, the bending moment diagram in this type of UDL, this is type of the bending moment diagram. Similar with type of UDL, your bending moment gets reduced. Your bending moment in the garden gets reduced, whereas the forces are transferred to the cable as a from this way is transferred as an axial load on the cable, and from the cable to the tower as an axial compression. So lot of bending moment in a cable state which is reduced in the garden, and garden sizes becomes lower compared to the normal cantilever or normal continuous distress garden bridges. To understand that, if you see that this load is coming here, so load is, there is a sine component and a cos component of the forces, and this is as an axial force is coming over here, and then this is the force is coming as a compression on the pylon, and pylon will also under the flexion because of this axial, this is a horizontal component, will have some bending on the pylon. But this is for one cable I am showing. So when there is a multiple cable, this becomes a more complex. Number one. Number two, these cables are not stressed all together at a time. So one cable is stressed, then after some time second cable is stressed, then after some time there is time gap is there because of your construction schedule. So because of the time gap, So there are, this cable has been stressed, and this, by stressing the cable is elongated also. So this elongation and the cable, next cable, when you are stressing, this stress in the cable also something important. So you have to do stress analysis when you have constructed up to this, you have stressed, and when you are adding another part of it, then you are stressing this. So already this is stressed. So because of this stressing, there is some effect on this earlier cable, and the elongation is also there. So always you have to do stage wise stressing, and there are, whatever you have already cast, there are number of days creep, shrinkage, and temperature effect. You have to long term these effects already with number of days, say 0 to 30 days, 30 to 70 days, 70 to 90 days, go on adding this creep effect of this and creep effect of the stressing. Both have to go on adding on that, but this is not possible in manually. So that's why we go for a specialized software. There are a number of softwares are available in the market. So you have to go those softwares, those who are actually take care of this stage by stage acting of the forces and transfer the forces accordingly. So this is the basic principle of that. But if you go for a extra dose bridge, when we do cantilever construction, we give a cable at the top for the tension at the cantilever tension at the top. So where we are getting only eccentricity of this much to take care of the stress tension at the top. So but when we are doing extra dose, the cable is outside the concrete, we are going through this, and we are getting much bigger eccentricity in the P into E effect, we are getting much more. So we are getting better nullifying effect for taking care of the tension, the T by A plus M by Z plus minus P by Z. When we are doing that, E effect is nullifying the M, the movement, negative movement, and that is nullifying. Here we are getting P into E effect. Accordingly, you have to fix up this E, accordingly the height has to be fixed up. So this is the tension zone where we are taking the tension bar outside. So that is what the basically principle of the cable stayed bridge. But and because these angles are much lower, and the anchorages, these angles of these cables are, in case of, I will show you the rotation of the cable. This next slide is coming. So this is what I am just showing you one analysis, that this is the axial force on the deck. The deck will also under the axial force, and there will be bending moment is much less in that case. That's why in a cable stayed bridge the deck is much slicker. You can see that Vidyasagar Setu, that deck is much slick compared to any other such span. It will be actually required much more higher depth, and that's why there is come slip. Now cable stiffness, you can if you do any software you need not to apply this, but it is a stiffness factor I am just showing you, and this is what I am trying to show you, that when you are stressing the cable, there is a tension, and sag tension thing is there. Sag is continuously, this phi angle is changing because of this tension is changing continuously. So because of this phi is changing and your anchor is rigid, so there will be some secondary effect of this because of the phi, some bending moment is inserted. Now if the cable is longer, and in your case in cable stayed bridge cable is longer and your tension on the cable is much higher, in case of that, so this effect is much more. Whereas in extra dose bridge this effect is much less because your cable angles are less, much flatter, and rotation of this point is much lower. So because of this, we are designing this cable for the axial load, and this stress is going on the anchorage point. So this, because of this reason, the long-term fatigue because of this flexion and the axial force has been imparted, and that's why the stress range for cable stayed bridge has been maintained as 0.45 of the UTS, and in case of extra dose bridge it was allowed up to 60% of the GUTS. In case of very wide deck, transverse flexure cause large depth of the deck system, such as 3-line pylon may be required. In Bardhaman bridge you have seen, because very wide bridge they have provided 3-line pylon, or Nivedita Setu, you have seen there is a single line pylon, but they have provided transverse pre-stressing on the deck. So that is what for a wide deck you require sometimes transverse pre-stressing or 3-line pylon. Vertical pylon does not give clearance problem, but required to tie transversely at the top. Very tall pylon at the top, you have to tie it. A-frame pylon gives a better stability, but sometimes better stiffness of the whole system, but sometimes it causes some clearance problem. You have to take care when A-frame pylon system has already number of places has been used. So erection of A-frame, yes, you can understand that it is a concrete pylon of A-frame, shuttering and concreting and etc. is a little bit difficult. Now cable arrangement, there are various types of cable arrangement is there. One is harp system, which is aesthetically very harmonious looking. Cables are parallel. These cables are basically this is because this gives a little lower eccentricity of the cable as far as flexion is concerned in the pylon is concerned. But because of this angle with the pylon and the deck is much flatter compared to fan system, so it is not that little less efficient. So maybe sometimes it is less economic, not that as economic as far as cable quantity requirement is concerned compared to the fan system. But fan system, one difficulty is there that all cables coming from the one source, so it becomes a very difficult to top of the pylon to arrange all the cables at that point, and it becomes a very cumbersome detailing issue with the fan system. So that's why people go for semi, harp and fan together. So some cables are provided within some zone. So it is neither fully harp nor fully fan system. So with this system, lot of structures, lot of cable stayed bridge has been constructed, and this is a more popular what I have seen, and asymmetric type of construction is very well, like Bardhaman is asymmetrical, there are Bikramjit Routh is asymmetrical in India, there are number of bridges are being constructed with asymmetrically. Now these are the various shapes of, I was just talking, this is the top has to be tied for a tall H type of pylon. Short pylon may not be required, this type of can be done, this is also, this is only one the ceiling pylon is right side type. So there is all this type one can follow. These are this is a single pylon. So this is a Nivedita Setu is like this. Even Bikramjit Routh is like this. So these are the steel type of superstructure. This is a 2 box girder or eye girder also you can follow with the cross girder. Pylon cable line is on this. You have to do proper stiffening to take care of the there is a concentrated force will be transferred from the cable. So this box girder or eye girder has to be properly stiffened, properly take the concentrated force, the local buckling of the plates and all to be taken care. This is an orthotropic plate kind of detailing. This is also being followed in the steel. This is also another method. This is a 2 box girder and connected by strut and truss system. So this is the cable line. This is a simple system. These are 2 eye girder and this is a big cross girder, and these are the cable line. Even our second look bridge is also having not 2 eye girder, 3 eye girders are there and 2 pylon line is there. This is a concrete deck. There is a small concrete girder and connected by cross girder, and this is the cable line. This is another way of doing the deck arrangement. This is a very popular deck arrangement that this is also a deck arrangement of Nivedita Setu. So this is the 2 struts coming here. This is the cable line. So you have to transfer the cable struts as a action of this action has to be taken. Otherwise, this deck will have a huge bending and this portion because of this concentrated load. So you have to give the struts wherever the cable is coming. So this type of thing has been followed in Nivedita Setu. Loads you all know, dead load, live load, superimposed dead load, seismic creep shrinkage, and stage-wise stressing. sequence, that's what I explained you have to take it. Cable type I have already told you 45% GTS, GUTS you have to consider, and see the angular rotation is 0.6 degree and the anchorage of the stay cable system and the cable stay system. But for external bridge, this is allowed 60% with 2 million load cycle. 2 million load cycle to 2 into 6 million load cycle or 45% where it is 60%. Because here angular rotation is much lower compared to this 0.6 degree in cable stay bridge. And with this, this is the specification we follow in cable stay and these both the type of bridges. Now, as far as cable protection system is concerned, earlier days we used to have the cable and the gap with the HDP gap is filled up with mortars. So a lot of bridges, I know Malaysia, this Penang bridge is also filled up with mortar, and later all the strands within the duct has to be changed, mortar has to be taken out. So this is the condition. So now the present situation is that the cable is galvanized and within a PE duct, HDP duct it was put, and inside there is a wax filling, and then it is put in another HDP duct. All the 7 wire strand is put in the HDP duct. So there are 3-4 layer of protection has been put in this, and I am just not going through the specification of this. These are the specifications given in the code. Only 5 minutes. Okay. So these are the specifications. You can go through the specification book. And then cable has 2 more things. There are dampers. There are anti-vandalism system. So dampers, I am not going into the detail. It's a long cable, specifically in cable stay bridge. Extra dose bridge, generally we don't require dampers. So dampers are required in mostly cable stay long bridges. Anchorage system, there are different type of anchorage systems. So in the pylon end, sometimes we give a live anchorage on the pylon, sometimes we give live anchorage on the deck. So accordingly the detailing and the design has to be done. And the anchorage system is, this is Presine's anchorage system. So they will deal it more detail. Only thing the bearing plate, and there is a wedge. And the cables here is much more number, not like our mistress cable. So cable anchorage is much bigger, much larger. So this is also that, this is the anti-vandalism tube, and this is a tensioning nut, means the cables are passing through this properly. So for that, this is the bearing plate. This is the bearing plate, and here the wedges are there from to where cables are passed, and this is stressed here. So there are one end is dead end and one is in the live end where you are stressing. Some cases like in Bardhaman bridge, I think so far I remember it was stressed from the pylon end. So some cases is from the deck end, or this is just stressing one of the space required. In steel, you have to develop a steel proper design the anchorage with steel in a steel girder, where all this the appurtenances of all anchorage system has to be inserted inside and stress it. So this design is very important, and you have to develop this design with basically better to do find element of this. This was done in one bridge there in Ranchi. So sometimes we provide a saddle also. So saddle has different type of design. BSL has one type of design, and nowadays the saddle is designed such a way that each strand can be taken out. So because replaceability of strand is nowadays very important. So to forward that, they have designed this type of shape of and they are giving another barrier against the corrosion, and also the friction is getting reduced. Even Presine's detail, both of them will talk about this much better. I'm just going fast. So they have also the similar system, maybe shape is different. ESI is also the similar system, shape is different. Now some design issues very fast. So this is the Bardhaman bridge in Ranchi. So this is 132 meter and 58 meter. So this is a very unsymmetrical end. So when the load is at the center, the backspan will going to have an uplift. So to take care of that, so this back span is made of concrete and the central span has been made of steel. So this is followed in Bardhaman also. And this I am not going into this pylon head is very complicated with 2 lines and 3 lines of stressing cables coming. Durgam Cherbu is also this 233 meter and 66 meter, but this is very unmanageable 66 meter condition. So we have to provide some vertical stressing at the 66 meter end, number 1. Number 2, we have done the guarded depth at the near the support, a lot of metal movement is coming. So depth has been very large at the near the pylon, and the center depth has been low. So 4.5 to 2.75 the variation. This is what I was showing you. This is Nivedita Shetu, same thing. I am just showing you there is a deck distressing is there because of this transverse dimension is 26 meter. Deck was very large deck, so for that and that there are 2 reasons. One is the shallow depth of the girder and the angle of the wave is very flat. So in that case the shear the component of the shear is coming as a tension on the deck. So though both the reasons you have to do a fixed stress on the deck. And second point is that if there is a 2 cantilever is coming, there is no support. That there is a expansion joint at the 2 cantilever end of the extra dose or cable straight bridge. You have to provide a beam inside the box, and the beam is taking care of the shear at that point, and we have to do the jointing properly with proper sliding bearing, and that detailing is very important, like articulation. So that number of cases this has created a problem. This detailing is very important. So when in closer segment, that is also another issue. When you are stressing, how much you are stressing and closing, you have only hand in that. You have to manage with the stressing and to closer segment. So that you have to calculate properly, touch with the side, so that the closer segment comes close and match in the levels properly. This is also another critical issue when you are doing the construction of a cable straight bridge or extra dose bridge. So okay, so these are the codes we normally use, FIB and PTI. And nowadays we have just published, just recently has published IRCSP 136 and 137, and these are the some aesthetics just going through the pictures of different bridges. So you know all these things. I think the different shape of the pylons, signature bridge you all know. These are the Durgam Cherbu already constructed. This is under construction. This is not yet constructed. So with this, thank you.
Of that big jump, we sputtered somewhat, and the bridge got completed by when it had been overtaken in its length. But the ambition was to build the longest bridge. Now, cables, are internal support, flexible support, and that is what makes the bending moment so much less compared to, in a structural standard. And the pylons, because they are compressive elements, often they are done in concrete, even though Vidyasagar Setu was a steel construction for different reasons and for saving on time. However, we lost on the time, but we had a more elegant picture. I would request Meghna to start her presentation, and please economize on the time.
Stage and the very lively audience here today. Thank you for being a part of today's event, and I'd like to briefly take you through one of the world's mega structures. It is a very, very bona fide concept that was developed in 2015 onwards and has taken long span bridges and the technology itself many leaps ahead. So today we will be discussing briefly about the third phosphorus bridge. Before that, for people who do not know Fresnay, I'll just quickly take you through what we do. Unfortunately, a part of my slide has disappeared. So if anything, please ask me and we have to discuss this. So we have about 7,300 employees in 60 countries through 75 subsidiaries. We do 10,000 projects per year, small and large size. the founder of our company is one Mr. Eugene Fressinet, a very visionary engineer who has patented even the vulcanization of elastomeric bearing technique. His biggest contribution, of course, has been the invention of post-tensioning system. We've all studied about it in our engineering days. Fressinet is part of the Soletanche-Fressinet group. We are a group of specialized subcontractors who operate under the Vinci Constructions banner. Vinci is the world's second largest construction company and also has other sister concerns like Vinci Energies and Vinci Concessions. So this is a brief history of what Fressinet has been doing over the last century actually. With beginning from post-tensioning to the development of cable stay system and wire systems with 2160 MPa strength. We all know post-tensioning strands generally have a strength of 1860 MPa, and there has been a lot of leap in technology for to cater for many long span bridges over the years. So we operate in various sectors such as civil, infrastructure, stadium, offshore structures, buildings, tunnels, etc. We will not spend too much time. Fressinet India has been in operation since 2007, and we have a fully integrated design office with more than 30 engineers working day and night. And our technical team is led by my colleague here who is present with us, Mr. Girinath Reddy. And he'll be happy to take your questions at the end of the session. Okay, so now to the topic that we have been trying to discuss, the third Bosphorus Bridge. There were already two Bosphorus bridges before that was constructed, mostly of the suspension bridge variety. That came from dynamic studies were beyond what anybody had actually imagined. So as already pointed out, the central suspended portion was held by hangers that descended from the main suspension cable. There were about 68 hangers. The two rows of hangers were anchored only 6 meters away from the longitudinal axis of the deck. So mind you, the deck width is about 59 meters, 58 to 59 meters. So the 6 meter width of the main cables, the distance between them, was actually very low. Due to this, there was very high torsion behavior in the deck. Additionally, the exceptionally high live loads increased the cable rotations because of the cable side variations, which was also described by engineer Senkupta sir before me. And this led to two direct effects. One, staying within the allowable stress ratio as per the codal requirements, the live load to dead load ratio, and the interference with the deck's geometric design and definition. How did we solve the first issue? So the first issue was solved by something on the right side, the special strands, HT strands. The first and the strength of these strands are about 1960 MPa, which was the world's first application. These strands were developed, although early in 2000s by Fressinet in association with some of our trusted suppliers. The reliability and the full compatibility had been qualified through R&D and full-scale testing. So when the project required the solution, it was already available with us, and made the decision to use them not only possible but also safe as far as delivery planning was concerned. Remember, the project had extremely tight deadlines. So the H2000 range anchors are compatible with 1960 MPa strands and were developed specially for the project and have been used for many mega structures from then on all over the world. Here a nut stroke from 300 to 500 mm was provided to allow for further detention or retention during the service life of the bridge, which could happen. Moving on, the large sag variations, which was our second problem, induced cable displacements within the anchor tube at their extremity. Such angular deviations were as large as 31 millirad, which is also quite uncommon in service condition, and 45 millirad in the ultimate state term. So to avoid cable damage, the diameter of the tube had to be about 1100 like 1.1 meter, the inner diameter itself. But this wasn't possible because the space that was allowed was about 600 mm. So there were many such decisions taken to avoid the cable damage, and the deck geometry, however, like I said, allowed only for 600 mm, and it was decided to create the fixed point within the cable pipe to move away from the anchorage system and at a certain distance. And this was done by using something called the fixed deviators, which you can see on the left side of the slide. So this decision further impacted the design of the anchor pipe, which has to withstand the transverse load imparted, and the position of the dampers, which are generally located closer to the deck. This is also true. Dampers are put very close to the deck. So 5 minutes. So, but we had to move it further away, and they were erected on the deck through these external hydraulic dampers. There were masts which were constructed, and the piston was mounted to the top between the cable and the mast. There were full scale testing that was done on the deviators, on the shielding of the cables to ensure for fatigue. The resistance was checked under high frequency vibrations. There was testing of the hydraulic dampers and the testing of anchorage, which was done. We have used anchorages as with strands of 151 strands, so that's very huge in terms of cable scale arrangements. So, and the very interesting part is generally cables are designed for 0.45 GBps, but in this project we were allowed to go only till 23%, which is 50% of that of what is normally allowed. So, and the anchorage was, the fatigue resistance of the anchorage was checked at a breaking load of 37.5 meganewton, which was almost the capacity of that testing machine. So it took about 4 weeks to do the testing. We'll see another small video. We'll try to be as quick as possible, and with that we will try to wrap up the session. So this is regarding the construction of the bridge.
things. I should say, first of all, I always give certain percent because these two actually there is the one which is not possible to achieve. So far I have achieved up to 1.4, not even 1.414. So this is the way I give actually our things. What sustainability that one actually that ASC it gives that promote understanding, advance skills, advocate responsible economic approaches, promote holistic approaches, promote performance-based standards. These are the things actually nowadays that things are coming up in buzzword that sustainable everywhere. And every time it comes that keywords. Once it was nanoscience, nanosilica, so many things. So now the things are coming actually sustainable. That's good, of course. And since you can read it, so I'm not actually reading on my own. So this is the thing. So basic things are there are the 4 things, and these 4 things I could make it in a tetrahedron. The 4 vertices of a tetrahedron. The thing is that even if you say sustainable, my understanding, my realization is that you can be always in the one face of the tetrahedron. It is not possible to keep all of them. If you want to keep environmental protection, optimal usage, economic development, quality of life will be hell because you will not be able to use AC, you will not be able to do anything. So this is the one actually. That's what I'm telling that you will be always in the one face of the tetrahedron. That is the one, and how far you will go that you try to think and try to understand. There are certain principles. These principles I have read in a Christus concrete book that is in the reference. So you cannot have everything. You cannot have something for nothing. Because just you cannot take the power. You have to purchase. Just like that. It is never too late. Please think that one. It is never too late. Whatever it is never too late. There is no progress without considering this. You have to take certain risks. Then only you will be able to progress. The proof of the pudding is in the eating. That means the cooking actually will always improve by cooking itself. Simplicity is always an advantage, but beware of over self-development. Don't try to go over self-development. That is dangerous. Do not generalize, but rather qualify the specific circumstances. The important question is how good, not how cheap an item is. Please do not go for that. You go for the quality. And obviously we live and learn, and there is nothing completely new. That means that one that before Newton also that gravity, all those things thinking was there, not the one the day that happened for, and then only he realized not like that. So everything, something, even say Einstein's relativity also, it is a process. Maybe he just break the thing at right time. Anyway, this particular one I would like to show in 1940 that Tacoma Narrows Bridge that actually collapsed. And the top one actually the old day, and later on actually they have manufactured, they have made another one, that is the new day. And this is the thing actually, this particular one here, what happens actually like the aeroplane, that wing that flutters. Similar fashion, they also flutters and it is in the other direction. So if you can go this way one and other way another direction, it moves actually and that way it flutters. And because of that, because that time actually that 1940, the aerodynamic effect, all those things were not known, that we did not realize that we have to consider. And obviously we have learned, and then you see that they first constructed first one, right one in 1950 and left one in 2007. That one actually they made actually in Tacoma Narrows Bridge, the two. Now American ASC actually they have made 10 greatest achievement, and one of them obviously the long span bridges, and which we are talking that mainly the cable supported bridges that we are talking. And bridges are actually called neck of lifeline. The roads, transport, all those things actually your railways, all those things are the lifeline. Because the thing is that if you start from the port to the city, and then you are either connected by railways or it is connected by the roads. And if anywhere stop, that is the food or anything are not supplied to the city, how many days it can survive. So that's why we call it lifeline, neck of lifeline, the bridges. And just simply give you the bridges actually 1914 that Pamban Bridge, Howrah Bridge 1943, then Mahatma Gandhi Setu 1982, Vidyasagar Setu 1992. And I have just chosen only these 4 bridges because I am studying bridge engineering also, because I have to, there are so many students from different parts of the country, and bridges are very much signature structure. And obviously I have to say that students ask to them, why you are giving this one, why not the other one, like that. So that's why I have chosen this place so that I can actually defend myself. And my defense actually not technical, my defense actually that one, in 2007, all of them actually published that post, the stamp. This is the one, the stamp actually, that one day I saw, and then I found, okay, that is the right thing, that one, that how I can defend that, and that's why I have chosen that. Now the thing is that regarding the bridges, one is that aesthetics, and there are certain kind of determinants. So these are the things actually, your function, proportion, all those things are there. We call actually color or wrong. Wrong is a wrong choice, because in this particular audience you will find out that everybody having that wrong, that whatever I like you don't like it, or whatever you like I don't. So this is the one actually the wrong concept actually. So that color actually, that way you can say. So this particular one we call it determinants, and by which actually the bridge to be made, and the bridge to be made stable also. That means if the thing is that beauty of that one, you see that I read somewhere, if you are looking at the structure, if you think it is unsafe, definitely it is unsafe. I repeat, looking at the structure, if you see the structure is unsafe, if you think so, then definitely it is unsafe. So that's why the determinant, this particular one, appearance, aesthetics, that is actually very, very important. So I am not going to all of them, so whatever you can find out that one, just to time. And why I have chosen out of this particular bridge, I personally feel, because the thing is that this bridge, if you can actually use the right tower to go up and go from the top floor, that which is actually glass floor, and then come down, even how it opens, everything it is shown every day. Visitors are actually open to visitors. What I feel after looking at that, when I visited that one, I found when they can do it and long ago, and it was also done during British period. So why they have not done the same thing for our Howrah Beach, the Ravindra Setu? That it is such a mammoth structure. Possibly, if we can have certain access with the staircase or elevator, like say your Eiffel Tower, so it could be used for a visitor, for a tourist one. Similarly, our second Hooghly Bridge also. When if it is done, because already we have leaved all those things, so, and some of other photographs are not allowed, this not allowed, all those things, but if it is open, and definitely the maintenance could be done properly. When everyday people are coming, and that is my realization, that it's not the one you have to keep it classified. You have to keep it actually open to everybody, and when you are maintaining, when you are using every time, every day, definitely it will be maintained properly. So that should be the one. That's why I have shown this particular figure. Now this particular, obviously our the question actually here, that which is actually now we are actually using this particular one. Actually, Mr. Ghosal actually, Amitabh actually he personally actually directed. Please see that photograph. I already, yeah. So this particular one actually there is, and this particular one I have taken from a book, because where from I can take it, I have taken from the book, and this photograph obviously my photograph I have taken. So they have used this particular one here. So main thing actually here, one of the burning issue actually you would say anchorage. Anchorage that is on steel, which is in the second Hooghly Bridge, and anchorage in concrete, which is there in the Nivedita Bridge. I do not know that why that no hue and cry. Definitely there is a problem in Nivedita Bridge. I personally feel, because it cannot be, because pollution, other things will be a burning issue there also. And definitely that possibly they are maintaining, that may be the another thing, and that's a good thing obviously. So this anchorage, that is your actually main actually problem actually, that where the problem comes, and there we have to actually keep it. Another one, the different types of cables. Nowadays we use actually locked coil, then parallel strand, that distressing strand or whatever we use it similar fashion, and then obviously the parallel wire, and this parallel wire actually used in second Hooghly Bridge. Now they are going to change actually with the travel style, whatever the cables they are going to use. And in the meantime, that your second Hooghly Bridge, there are actually you are having 152 stay cables. Now these are the parallel system, and where you are having the 7mm wires, filament type, HDP. So those things actually they are the master that, but these things actually deteriorated, and that we have to look into it. So three things mainly: corrosion, which is mainly due to environmental conditions, humidity, moisture, fatigue, and extreme events, earthquakes, fires, blast, impact, it may happen. So these are the three things that you have to actually keep it in your mind for inspection. For cable stayed bridge, actually you are having, there are so many points where you have to look into. There are the things that even you would say railing also, that crash barrier also, that also you have to do it. But the major things actually in the cables we are having at the top end and the bottom end. And similarly we are having here in this one holding down cables, that which is actually holding the two ends and bearings. So these are the three things that you have to actually keep it. So stay cables, holding down cables, and bearings. So stay cables, pylon and deck anchorages at the top level, at the deck level, pylon and tower components, and damping systems. So these are the things actually you have to inspect, you have to find out. And obviously you can say that if you go to a doctor and if you tell the doctor that I shall not show you the patient, but as many as tests you want to prescribe, I shall do it, but I shall not show you the patient. Do you agree with that? The doctor will say no, because the thing is, doctor at least once he will see the patient on his own naked eye. Similarly, visual inspection for any structure, it is very much required. You just simply cannot just do it that you are testing all those things, but visual inspection is also equally important. Now another one, we are having suspension bridges. There are different components at the top, because already they have already told the different things also there. And here also that you are having anchorage, you are having suspenders, you are having main cables. So all those things you are having, cable rope, all those things. Wherever actually you are having the problem, wherever the dust accumulates, all those things, the rain also accumulates. So those are actually your problem, and those things you have to see. And it's not like that you will see every 5 years. You have to see a regular interval. You have to actually look into it, and you have to find out whether there is a problem, and then only you can do other things. So obviously here main suspender cable, tower and cable saddles, cable bands, suspender cables and connections, sockets, anchorages. So these are the things to be inspected. Now regarding structural health monitoring, nowadays also we keep on doing that. One is the traffic, vehicles and pedestrians, bridge, so cable force, stress and deformation, material testing, angular movement. If you go for environment, you have temperature, humidity, wind speed, rainfall, solar radiation, and air quality. So these are the things actually you have to that at least you have to keep it in three different headings. So traffic means just if it is a rail bridge, so railway or whatever you are having. Then you are having heterogeneous vehicles also. Vehicles are also heterogeneous. So that also you have to keep it in your mind. And another problem is the bridge deck. The bridge deterioration of the top of the bridge deck, that also creates problems. There is one is called vehicle bridge interaction. If the top of the deck actually not proper, then obviously there will be another actually your vibration due to that. And that is called actually vehicle bridge interaction. Now regarding non-destructive testing, we can have actually 4 categories: external or surface defects, internal or subsurface defects, structural steel cables, tendons, ropes in this particular cable supported bridges, vision-based monitoring methods. So those things actually you can have different heading. So obviously external surface defects means visual inspection, dye penetrant testing, magnetoparticle testing, eddy current method. There are so many methods are available. Similarly, you can have ultrasonic testing, acoustic emission testing, infrared thermography testing, radiography testing. So these are the testing you can do. or ultrasonic testing, magnetoflux, leakage, vibration method. So these are the things actually mainly we shall talk these three, which mainly we use for actually your state cable, actually your state cables or holding down cables. So first one, ultrasonic, which mainly we do it at the two anchorages.
Just quickly take you through the material part of the cable stay bridges. First of all, it's an honor for all of us to be on this dais with this with the dignitaries from the engineering fraternity, and with all of you. It's an opportunity. We are happy to be here. Okay, I will just start the presentation with my colleague Rajoshri, who will present the part of lock coil and the spiral strand portion, and I will take you through the bonded LRPC strand, which is the one of the main component of the cable stay infrastructure.
And respecting the time constraint, I am directly going to the requirement of the cable stay bridges. Cable suspension bridge, cable stay bridge and arch bridge with suspenders. Mainly here we are using the cables over there. Lock coil cables and spiral strand for the cable suspension. Lock coil P-coated bonded LRPC strand for cable stay bridge, and lock coil spiral strand P-coated bonded LRPC for the arch bridge suspender. And the main thing is, as per the standard EN 12385/10 and IS 9282, the most preferable wire rope is lock coil and spiral strand because of their high MOE value, modulus of elasticity. Main thing in lock coil, bridge rope, that is minimum 2 layer of jet section is there. Jet section you can see over there. It is, when it is prepared, manufactured, it is connected with each other like, can you see my hand? Like there. So there is a chain of this type of joints over there who protects the inner surface, circular section, inner surface of the rope, which is core, totally prevented from the outer environment, dirt, dust, oil and any other type of icy area. So it is more preventive than other products, and for this it is, life of this is more or less, nearly you may say it can be long for 100 years. And then spiral strand is also having a great MOE. That is why these two products are heavily used in the structural application. Now if we see the advantages, there is the advantages of flexibility, corrosion resistance, resistance to abrasion, high strength, high modulus of elasticity. In lock coil bridge rope, we can found up to 180 gigapascal of modulus of elasticity, which is a great achievement for the cable stay bridges. Here is a comparison. If we compare a rope size 50 millimeter, as per IS 9282, they recommended 3 type of ropes over there: round rope, spiral strand rope, and lock coil rope. If we consider 50 millimeter, a round rope of 737 construction of 1570 grade, it will give us 1250 kilonewton MVA. For the same spiral strand of construction 1 into 127 of same grade 1570, it will provide us 2005 kilonewton breaking load. But in the but for the full lock coil, though it is lower grade, that is 1470, it is providing us 2056. If it is 1570 of 50 millimeter, it will give around 2350 and above braking load. So you can see the differences of braking load of same size of the rope or in different construction, that is round rope, spiral strand and full lock construction. It is clearly shown that the full lock construction has the better braking load, so load carrying capacity is much higher. In the right side of the table, you can comparison, here is a comparison with 50 millimeter round rope with spiral strand and lock coil. For the 50 millimeter round wire rope, equivalent, nearly equivalent spiral strand diameter should be 40. So you can differentiate that. 10 millimeter we can reduce by using the same, by keeping the same braking load, that is 1250. So there is a saving of material and saving of weight. And similarly for lower grade, not for 1570, for lower grade 1470 of lock coil, it is equivalent to 39. And if it is 1570, it is at around 35 to 36 millimeter. So from 50 millimeter to 35 to 36 millimeter. So there is another huge saving on load, which is directly related with the dead load of the beach. Similarly, you can see if we take 50 millimeter of spiral strand, equivalent round rope size will be 63 and equivalent lock coil diameter will be 49 millimeter. So there is a saving of huge material by using full lock coil and keeping the same braking load. We are reducing the dead load of the construction.
What about the avoidance of corrosion? Is lock coil?
Yes. That is why at first we I am saying that the jet section of the lock coil is like my hand. So there is no chance. There is a barrier. Minimum 2 lock coil. I am coming to that point. This is the MOE. Everybody know regarding MOE. What is MOE? So first, permanent constructional stress, which cannot be able to avoid, it will be there. But the elastic stretch, which can be removed by using pre-stretching method. And by using pre-stretching method, you can find the in table that the manufacturing, during manufacturing, the elastic MOE of the full lock coil is 103 GPa. But after pre-stretching, this GPa moves 131 GPa and it can be extended up to 180 GPa, which creates a sustainable product for the structure. Here, as sir said, what will be the effect of lock coil? You can find that minimum 2 layers of jet section will be there.
The main the stands, why we normally use this quick bonded adhesive stand, because of strength, durability, corrosion protection, higher resistance to fatigue, ability to withstand deflection, ease of installation and transportation, faster to build, and is definitely cost effective, as our earlier speakers already have mentioned about this. Normally, we have to follow two various international standards. One is FID Bulletin 89 and the PTI DC 45. Other applications and international standards are also there, like NFA 35035. So basically, this pre-coated bonded adhesive strands, some precisions are required, like the state-of-art extrusion lines from the manufacturer point of view, highly engineered wax insertion mechanism, sophisticated patenting and galvanizing line, and maximum control measure during stranding and the stress relieving of the galvanized strands. And the specification requirement of the components of these, we require the super clean steel for basically the wire rods, and the zinc purity has to be 99.995%. Special filler compound, the wax is being used for this pin-coated bonded electrical strands, and the special grade of engineered polymer. This is the specification of the standard pin-coated bonded electrical stand, which is based on the FID 89 specification, which normally all the manufacturers and the designers follows during the designs of the bridges. This is the flow diagram of the manufacturing of the pin-coated bonded LFP stand. Just a small pictorial presentation for all of you to understand. We get the wire rods and it gets cleaned through the picking house, and the galvanization and the patenting process takes place. And after that, wire drawing and stranding takes place. After that, heat treatment process and the stress relieving process takes place, and then extrusion, like the wax insertion and the plastication on the strands. Then it gets packaged for the final delivery. So various tests has to be conducted for this pin-coated bonded LFP stands, and all the manufacturers and the construction companies, the stackable erectors has to follow this. There are 4 stages for for the bare stands, for the filler material, the wax, for the polymer, and for the finished strands. There are various tests being conducted, like all this you can see the diameter measurement, cut test, curvature test, fatigue test, breaking load test, everything. After that, filler material like wax, the cold resistance, congealing point, corrosion test, and heat resistance, etc.
We had speakers from Usha Martin Limited, Mr. Partho Dotto, General Manager. He could not attend, but he sent his. Mr. Partho Dotto, may I request you to kindly come up on the dais?
এই অ্যান্সারটা তুমি দিলেও হবে। প্রশ্ন পড়া মতো কিনা ফার্স্ট অফ অল দিদি, গুড কোশ্চেন আর ব্যাড কোশ্চেন?
Yes. May I request Engineer Shamaprasad Dotto, Engineer Amitabh Ghoshal, and Engineer D.A. Chakrabarty to kindly felicitate the speakers.
একসঙ্গে দিতে যাবে?
VSL could not attend, though they have sponsored our.
Just number 8319, kindly just shift the car a bit. Car number 8319. Thank you.
VSL could not attend today's performance because
corporate. This is an international event organized in one place in the country every 5th year. West Bengal had the privilege of organizing this event in 1998, and this is the second time West Bengal is organizing this event. There will be many international participants and also very eminent speakers will be there from India, various places will be there. It will be very interesting presentation will be there. I would request you, all of you, not to miss this chance. Please avail this opportunity to attend this innovative World of Concrete. Thank you. Now I would request Orko Dasgupta to start your presentation.
Nowadays, this use of structural health monitoring has come across and along all the major structures. So by definition, it is an assembly of some sophisticated electronic devices which we installed on the civil structures, which are measuring the physical parameters and assessing the actual conditions of the structures. You can see in the image that there is the data acquisition unit which is being placed in the computer on the bridge and which is being tested by the engineers. You have accelerometers which are placed on the cable stage, some strain gauges being installed on the steel deck. So an assembly of all of these together gives us some data, relevant data, which can be analyzed to understand the structure's condition. Now the different phases where structural health monitoring has its uses. It can be used during initial construction, it can be used to have some inspection and maintenance. We can use it to investigate certain particular areas of concern, and finally we can use it for some renovation work. So the basic flowchart of how this system works remains the same for all the projects. First we have the structure. From there we need to define the scope, like what exactly are we trying to monitor. It may be vibrations, it may be stresses, it may be environmental loads, it may be traffic loads, and depending on the scope, the sensors are selected. So first the scope, then the sensors. Depending on the sensors, the data acquisition unit which is being placed on the structure is selected. Finally, all this data is fed into a software and we have this viewed as an output in any interface. This is a flowchart of a typical bridge structure health monitoring where we have the sensors placed all along the structures. Then all these signals is placed into these A to D converters. As you all might be knowing that sensors generate analog signals which cannot be led and traveled by longer cable lengths. So these A to D converters are basically responsible for changing this sensor data from analog to digital, which can be traveled via longer cable lengths. Now the question comes, why not wireless? Why are we still using wires? The basic answer to that will be wireless data has a less range of frequency. Like I cannot collect 100 data points every second, which are required for dynamic analysis in wireless system. That is only being possible for wired systems. So even after so many days, we see that wired systems has predominantly a greater advantage than wireless systems. Finally, all this data is fed into a computer on the bridge, which transmits all this data wirelessly to the server. The basic objective of the server is to collect all those data, filter out what is unnecessary, keep the necessary data, and change it to human understandable prompts.
Monitoring is an important part, and cable stayed bridges, actually cable supported bridges, these are these cable supported bridges have a lot of advantages, but also these structures are very delicate structures, and that is why this regular monitoring by now technology is available. Now it actually sensors, actually he has explained very nicely how sensors can be placed, and this is now this appropriate locations of putting sensors and properly putting sensors and analyzing the data received. Those are also important. Thank you, Dr. Dasgupta, for your very nice presentation. Now I would request Pratik Sen for making presentation on bearings and expansion joints of bridges.
I discuss only three major topics. First, I talk about a little bit about reactions in cable supported structures, because those are really important to actually determine where the bearings and expansion joints come. And then we talk about the two boundary elements, which is bearings, structural bearings first, and then expansion joints. While I was trying to browse through like how do I actually explain reactions in cable supported structure, so this idea popped up on the internet, like it's taken from the internet. But there's a really nice illustration. So say for example you extend your two arms and you try to tie it and you hold your arms, right? And for obvious reasons, for all the weight of the arms is held by the strings, and more you put weight, the more of the reaction that goes through your body and the knees. So very easily spoken for how the reactions like. So if this is the weight, and then it is the tension forces in the strings, and then the final reactions. Now if I try to take this to bridges, very similar. So first you have the weight of the deck, the dead load, live load, etc., SIDL. Then you have some tension forces in the cables, and then the reaction in the pilot, right? The compression reaction in the pilot. Now, in particular, if we go, say, like here we have an abutment, so like if we go to this area, and we try to understand what the bearing would be like how do we, what the bearings, what are the forces that can come on the bearings. So there can be forces like this, compression forces, yes. There can be tension forces. There can be movements, like it has to allow some movements. Another big challenge, the bigger challenge, especially with such cable supported structure, is the frequent load reversals. So like there could be a bearing support, or there could be a support which would demand that at times it is in compression, at times it is in tension. So such could be the scenario. Then I go nearby, like to the main pylon. In the main pylon, once I talk about bearings, there's yes, there could be it could be any kind of design. Obviously, it could be monolithic also. Like it need not be very like this exactly. So compression bearings and some bearing which will allow some movements, and even you can have restrainers so that it does not hit the pylon. So in such manner, so I come to the next topic of boundary element, which is structural bearings. In the structural bearing part, as I've already spoken about, there can be compression bearings.
Very important elements of a bridge structure. You see, actually proper design of it, earlier we had very limitations about choosing of bearings and expansion joints. Now there are bearings and expansion joints are available which can take care of various types of loads, particularly when we are going for long span bridges. These are very important. Actually, there the movements are also very high, both translational movements and also rotational movements, and also spans being very high. The compressive loads are also very high. You have very correctly mentioned that this expansion joints are very often overlooked.
Transportation problem in the world, and starting from UK, Germany, and Australia, they all depended on aerial roadways for transportation of material like coal from mines to recycling. And at that time, the transportation system which are available today were not available. Then done by the we are killing people on the road, and secondly, this poisonous gases which are in the environment. And traffic jam is also another aspect which actually takes away a good percentage of time, travel time, nearly 40%. That is recorded in various.
We had ropeways. In some of the ropeways have been closed, but definitely where it is possible, we can have these options.
Sir, that's complete. Just again.
Dr. Major Dan from IIT Kharagpur, Engineer Pho-8777763590, and his team, and engineers from BSL India. We are thankful to the moderator of Technical Session 2, Engineer Pho-8777763590, and Engineer Shekhar Chakraborty, Managing Director of Conveyor and Rotor Services Private Limited, Engineer Orko Dasgupta from Mageva Brake Products.
আজকের যে ফাংশনটা হলো, ইভেন্টটা, এটা করাই হয়েছে যাতে এই কোভিডের সময় আমাদের সাধারণ অ্যাক্টিভিটিতে যে ছেদ পড়েছিল সেটাকে ঠিক মতন ফিরিয়ে আনার জন্য। আগে আমরা একটা রেগুলার বেসিসে ইঞ্জিনিয়ারিং ডিসকাশনস করতাম এবং সবাই আসতো, প্রত্যেক বুধবার ইনস্টিটিউশনে, কিন্তু সেই ধারাটার মধ্যে ছেদ পড়ে গিয়েছিল কোভিডের জন্যে। এই 3.5 বছর 4 বছর বাদ যাওয়ার পরে এখন আমরা আবার সেটাকে, সেই জীবনটাকে ফিরিয়ে আনতে চাইছি। সেদিক থেকে আমরা মনে করি আজকের ঘটনাটা খুব সাকসেসফুল হয়েছে এবং সবাই মোটামুটি এটাকে এনজয় করেছেন। এটা বোঝা যাচ্ছে যে বেশ কিছু লোক 3টের থেকে আমাদের ফাংশন হয়েছে, 8টা বাজে 5 ঘন্টা পরেও এরা যে ছিলেন আমাদের উৎসাহ দিয়েছেন, এটা খুব আনন্দের কথা। এবং এই সাবজেক্টটা আমরা চুজ করেছিলাম যাতে করে কলকাতার লোকে বুঝতে পারে যে তাদের শহরে যে দুটো ব্রিজ আছে, বিদ্যাসাগর সেতু এবং নিবেদিতা সেতু, এর মধ্যে যে বিশিষ্টতা আছে সেটা যাতে বুঝতে পারে এবং তার মধ্যে বিদ্যাসাগর সেতু যে আজকে সারানো হচ্ছে, কেন এত তাড়াতাড়ি সারানো হচ্ছে, এটাও যাতে বুঝতে পারে। সেদিক থেকে আমরা মনে করি আমরা সফল হয়েছি, লোকের কাছ থেকে ভালো উৎসাহ পেয়েছি, সবাই প্রশ্ন করেছেন, এইটাই খুব আনন্দের।
ব্রিজের যে স্প্যানটা আমরা যদি বড় না করি অসুবিধে, মানে নদীর মধ্যে খালের মধ্যে যদি আমাদের সাপোর্ট থেকে যায় তাতে জল চলাচলের অসুবিধা হয়, বিশেষ করে যেখানে নেভিগেশনের ব্যাপার থাকে সেখানে অসুবিধা হয়। সেই জন্য লং স্প্যান ব্রিজের জন্যে আমাদের আগে যেরকম ব্রিজ করতাম তার থেকে আমাদের সেই ব্রিজগুলো এখনও হচ্ছে, যে কংক্রিটের ব্রিজ, এমনি স্টিল গার্ডারের ব্রিজ, কিন্তু সেই জন্যে কেবল সাপোর্টেড ব্রিজ, যেটা আমাদের এখানে বিদ্যাসাগর সেতুতে হয়েছে, যেটা নিবেদিতা সেতুতে হয়েছে, যেটা মাঝেরহাট ব্রিজে হয়েছে, এই জিনিস মানে সেইটা নিয়ে এই ব্রিজগুলো কিন্তু তার ডিজাইনটা একটু অন্য ধরনের, শুধু অন্য ধরনের নয়, এটা কিছু বড় স্প্যান করার জন্য এই ব্রিজগুলো। তাছাড়া এই ব্রিজের কনস্ট্রাকশনের মধ্যেও অনেক কিছু মানে দেখার আছে। এর ডিজাইন কনস্ট্রাকশন শুধু তাই নয়, এই যেভাবে যে কোনো ব্রিজেরই একটা স্ট্রাকচার হলে সেটার অ্যাকচুয়ালি মানে সেটা টাইম টু টাইম সেটা দেখার দরকার আছে, ঠিক মতন তার মেনটেন্যান্সের দরকার আছে। সেই জিনিসটা আজকে কিন্তু তুলে ধরা হয়েছে। মানে একটা স্ট্রাকচার করলাম তারপর আমি ছেড়ে দিলাম, সেটা তো হয় না। আর তার জন্যে এখন যে অনেক অ্যাডভান্স টেকনোলজি হয়েছে, সেই জিনিসগুলো আজকে এই যে আমাদের আছে প্রোগ্রাম হলো, তাতে সেগুলো ডিসকাশন হয়েছে, সবাই খুব স্বতঃস্ফূর্তভাবে সেটাতে যোগদান করেছিলেন। সেই জিনিসগুলি সবার কাছে জানানো, আর তাছাড়া আমাদের কেন এগুলো হচ্ছে, কি দরকার, তারপরে টেকনোলজি কতখানি অ্যাডভান্স হয়েছে আমাদের, তারপরে যে কোনো একটা ব্রিজ হয়ে গেলে সেটা যে দেখে যেতে হয় সময়, যেটা মাঝেরহাট ব্রিজেতে অনেকগুলো সেন্সার বসানো হয়েছে। আস্তে আস্তে টেকনোলজির তো অনেক অ্যাডভান্সমেন্ট হচ্ছে, সেইগুলো এখানে কিন্তু বলা হয়েছে। এছাড়া আমাদের আরেকটা জিনিসও বলা হয়েছে যে রোপওয়ে স্ট্রাকচার, রোপওয়ে আমাদের অনেক জায়গাতে রোপওয়ে আছে, সেটা এমনি লোকজনের জন্য কিভাবে ব্যবহার করা যায় সেটাও আমাদের এখানে ডিসকাশন হয়েছে।
স্যার, আজকের এই সেমিনার সম্পর্কে আপনি কি বলতে চান?
আজকে আমরা যে সেমিনার এবং ইভেন্ট প্যানেল ডিসকাশন করলাম, এটা হচ্ছে কেবল সাপোর্টেড ব্রিজ। আজকে আপনারা সেমিনারে দেখেছেন যে কেবল সাপোর্টেড ব্রিজ 3 রকমের হয়, শুরুতেই বলা হয়েছে। সাসপেনশন ব্রিজ যেটা হয়, সেরকম ব্রিজ আমাদের পাহাড়ি অঞ্চলে প্রচুর আছে, সেটা আমরা আজকে খুব একটা করিনি। যদিও বসফরাস ব্রিজ একটা হাইব্রিড ব্রিজ, সেখানে কেবল স্টেট যেটা আমরা আলোচনা বেশি করেছি সেটারও রয়েছে, আবার সাসপেনশন ব্রিজেরও অ্যাপ্লিকেশন রয়েছে। এই ধরনের ব্রিজের এখন আমাদের ভারতবর্ষে প্রচুর হচ্ছে। আমাদের কলকাতা, ওয়েস্ট বেঙ্গলেও যেমন অনেক তৈরি হচ্ছে, তেমনি ভারতবর্ষে অনেক বেশি সংখ্যায় তৈরি হচ্ছে এবং নানা রকম ঘটনা ঘটছে। এবং যেগুলো পুরনো ব্রিজ তৈরি হয়েছে আর দেশে বিদেশে, সেগুলোর টেকনোলজি, সেগুলোর কেবলের নানা রকম প্রোটেকশন সিস্টেম নানা রকম ছিল, যেগুলো আমরা বিভিন্ন লেকচারে বলেছি। এবং আজ সেগুলোর থেকে অনেক ইমপ্রুভ টেকনোলজি এসছে, যাতে আরও লং টার্ম, যেটাকে আমরা অনেক বেশি দিন ধরে এগুলোর আয়ু, এগুলোর যেটাকে আমরা ইংরেজি ভাষায় ডিউরেবিলিটি বলি আমাদের টেকনিক্যাল টার্মে, যেটা অনেক দিন বেশি থাকবে, সেরকম ধরনের টেকনোলজি এসছে। অবশ্যই এটা আরও সময়ে আরও এর উত্তর দেবে, কিন্তু সেসব জিনিস আজ আমাদের কাছে হাতে এসছে এবং আমাদের কাছে অনেক এগুলো, যেমন আজকে কথা বলো, যখন সেকেন্ড ব্রিজ ডিজাইন হয়েছিল, বহু বছর আগে, আজ থেকে 30 বছর আগে, তখন হাতে হাতে কাজ হয়েছিল। আজ আমাদের কাছে আরও অনেক ভালো ভালো অঙ্ক কষার অনেক টুলস এসছে, সেখানে আরও ভালো করে অঙ্ক কষে আরও ভালো করে অনেক অ্যাকুরেটলি করতে পারি। দ্বিতীয় কথা হচ্ছে লং স্প্যান করে আমরা অনেক কিছু অ্যাডভান্টেজ পাচ্ছি। এই যে রেলওয়ে লাইনের তলায় আমাদের সাপোর্ট না দিয়ে করলে অনেক সেফ, মানে রেলওয়ে ইয়ার্ড যেখানে ঘন ঘন লাইন থাকে, সাপোর্ট দিতে গেলে, পিয়ার দিতে গেলে আমাদের অনেক অসুবিধা হয়, সেখানে লং স্প্যান করতে গেলে এছাড়া কোনো উপায় নেই। দ্বিতীয় কথা হচ্ছে নদীর মধ্যেও যদি আমরা ঘন ঘন সাপোর্ট দিই তাহলে নদীর জলের যে ফ্লো, যে প্রবাহ, সেটা বাধাপ্রাপ্ত হয়, তাতে নানা রকম অসুবিধা হয়, জলের লেভেল বেড়ে যায়, ফ্লাড, বন্যা ইত্যাদির পসিবিলিটি বেড়ে যায়। জলের লেভেল বেড়ে গেলে চারিপাশে জল ছাপিয়ে বেরিয়ে যায়। সেসব অসুবিধার থেকে কমানোর জন্য জলের নদীর যে ফ্লো বা এই যে সায়েন্সটা আছে, সেই বিজ্ঞানটাকে যাতে ঠিকমতো চলে, তাতে যত সাপোর্ট দূরে দেবো তত ভালো। দূরে দেওয়া মানেই আমাদের লং স্প্যান, লম্বা স্প্যানের ব্রিজ করতে হবে। তখন আমাদের এই কেবল স্টে ব্রিজ একটা বা এক্সট্রা ডোজ ব্রিজ, যে দুটো যে ব্রিজ আলোচনা হলো আজকে, সেগুলো আমাদের একমাত্র সলিউশন। এবং এখানে যে মডার্ন সিস্টেম আসছে, সেই সিস্টেমগুলো আমরা আজ ইন্ট্রোডিউস করতে পারছি আমাদের কাছে। আমাদের দেশে আজ কেবল ম্যানুফ্যাকচারিং হচ্ছে, কেবল তৈরি হচ্ছে আমাদের দেশে। আজ আগে বিদেশি কোডের উপর আমরা নির্ভরশীল ছিলাম, এখন ইন্ডিয়ান আমাদের দেশের কোড বেরিয়ে গেছে, গাইডলাইন যাকে বলি, যার উপর বেস করে আমাদের ডিজাইন, ইঞ্জিনিয়ারিং, কনস্ট্রাকশন সমস্ত কিছু তৈরি হয়, সেগুলো সব হয়ে গেছে। এইগুলোর উপর বেস করে আমরা আজ করতে পারবো। এবং আমাদের কাছে মানে নলেজ, মানে জ্ঞান এবং কনস্ট্রাকশনের জ্ঞান সব কিছু আমাদের দেশে আজ আছে। এবং সেইখান থেকে দাঁড়িয়ে এর সম্বন্ধে আরও অ্যাওয়ারনেস, আরও নলেজ, সেটাকে আরও বেশি করে সবার মধ্যে ছড়িয়ে দেওয়া, এবং এগুলো কি করা হচ্ছে না করা হচ্ছে সবাই যাতে আরও বেশি করে জানে, সেই উদ্দেশ্য নিয়েই আমরা আজকে এই সেমিনারটা, এই প্যানেল ডিসকাশনটা আমরা করলাম। সেখানে আমরা ব্রিজের সাপোর্ট, ব্রিজের কীভাবে ইন্সপেকশন, মেনটেনেন্স করা হবে সেদিকটাও, কারণ মেনটেনেন্সটাও ইম্পর্টেন্ট। মেনটেনেন্স না করতে পারলে ব্রিজ বেশি দিন সব কিছু ঠিক থাকবে না, সেসবগুলো আলোচনা করা হয়েছে। এবং সেসব দিক থেকে আমি মনে করি আমরা যত আমাদের সবাই এসেছিলেন যারা পার্টিসিপেন্ট, সবাইকে আমরা ঠিকমতো বোঝাতে পেরেছি এবং এটা খুবই সফল একটা সেমিনার করতে পেরেছি। এবং এইটুকুই আমার বক্তব্য।
এইটা আজকের যারা শ্রোতা ছিলেন তাদের মাঝখানে আশা করি ছড়িয়ে দিতে পেরেছে। এর ফলে আজকে যে সমস্ত ইঞ্জিনিয়ারিংয়ের ছাত্রছাত্রীরা উপস্থিত ছিলেন, আশা করি তারা উপকৃত হবেন। আগামী দিনে তারা যখন ইন্ডাস্ট্রিতে আসবেন, তারা এই আজকের যে অভিজ্ঞতা তারা নিয়ে গেলেন, এই অভিজ্ঞতা অবশ্যই তাদের কাজে লাগে। আর ভবিষ্যতে শুধুমাত্র সিভিল ইঞ্জিনিয়ারিং বা মেকানিক্যাল ইঞ্জিনিয়ারিং বলে কিন্তু কাজ হবে না ইন্ডাস্ট্রিতে। সমস্ত ইঞ্জিনিয়ারিং ডিসিপ্লিনকে হাতে হাত মিলিয়ে কাজ করতে হবে, সেই জায়গায় কিন্তু আমরা পৌঁছে গেছি। এর সাথে আরও বেশি করে আসবে আর্টিফিশিয়াল ইন্টেলিজেন্স এবং মেশিন লার্নিং। আজকে কিছু বক্তা যেমন স্মার্ট টেকনোলজির প্রয়োগের ব্যাপারে তারা হাইলাইট করলেন, এই স্মার্ট টেকনোলজি কিন্তু কনস্ট্রাকশন সেক্টরে এবং মেশিনারি সেক্টরে আরও বেশি করে প্রতিনিয়ত সেটার প্রয়োগ বাড়ছে এবং আগামী দিনে বাড়বে। আমরা ইনস্টিটিউশনাল ইঞ্জিনিয়ার্স, কনসাল্টিং ইঞ্জিনিয়ার্স অ্যাসোসিয়েশন অফ ইন্ডিয়া এবং ইন্ডিয়ান অ্যাসোসিয়েশন অফ স্ট্রাকচারাল ইঞ্জিনিয়ার্সের পক্ষ থেকে এই ইন্টারডিসিপ্লিনারি ইঞ্জিনিয়ারিং এর কিছু অংশ আজকে তুলে ধরার চেষ্টা করলাম। আশা করি ভবিষ্যতেও আমরা এই ধরনের অনুষ্ঠান অর্গানাইজ করতে পারব, যাতে ইঞ্জিনিয়ারিং সেক্টর এবং ইঞ্জিনিয়ারিং সেক্টরের যারা সদস্য তারা উপকৃত হবে।
আজকের এই যে সেমিনার, এই সম্পর্কে আপনি কি বলতে চান?
আমি সিইএআই এর ইস্টার্ন রিজিয়ন এবং নর্থ ইস্টার্ন রিজিয়নের সেক্রেটারি। যখন 3-4 মাস আগে দায়িত্ব পাই, তখন হয়েছিল যে আমাদেরকে একটা সেমিনার ইমিডিয়েটলি করতে হবে। তো মাঝে পুজো টুজো পড়ে যায়, আমরা করতে পারিনি। কিন্তু এইটা আমরা খুব শর্ট নোটিশে, প্রায় মাত্র 15 দিনের একটা নোটিশে 3টে সংস্থা মিলে এই সেমিনারটা আয়োজন করি এবং 5-6 জনের অক্লান্ত চেষ্টাতে আমরা এটা খুব সফলভাবে করতে পেরেছি। এটা আমাকে খুব আনন্দ দিচ্ছে। আশা করা যায় আমরা ভবিষ্যতে আরও অনেক বড় সেমিনার করতে পারবো। এবং যে ইঞ্জিনিয়ারিং সেক্টরটা নিয়ে আজকে আলোচনা হয়েছে মূলত সেটা হচ্ছে কেবল সাপোর্টেড স্ট্রাকচারের উপরে, কিন্তু আমাদের যারা আজকে এসছেন বা অনেকেই গুরুত্বপূর্ণ ব্যক্তি যারা হয়েছেন এসছেন তারা বলেছেন আরও বিভিন্ন বিষয় নিয়ে আমাদেরকে করতে, এবং আমরা চেষ্টা করছি যাতে ভবিষ্যতে আরও অনেক বড় সেমিনার আমরা করতে পারি। এবং সবাই যারা এসছেন তাদেরকে আমি ধন্যবাদ জানাই। যারা বক্তা ছিলেন তারা অত্যন্ত মূল্যবান বক্তব্য রেখেছেন, এবং যারা শ্রোতা হিসেবে এসছেন তারাও অনেকে প্রশ্ন করেছেন এবং খুব আনন্দ পেয়েছেন আজকে সেমিনারে। তো এই সর্বাঙ্গ সুন্দর একটা অনুষ্ঠান করার জন্য আমি সবাইকে ধন্যবাদ জানাচ্ছি।